I'm going to find the change gears needed to hob a helical gear without using a differential. The parameters will be for a Barber-Coleman number 3 gear hobbing machine. I'm entering 12 as the index constant and 0.075 for the feed constant. I'll paste the helix angle. The normal diametral pitch is 20. 33 for the number of teeth. Left hand for the hob, left hand for the gear, cut in the conventional direction. Now, changing to the change gears page to show that 30 through 80 are selected. The results are change gears chosen from user entered, available gears. The feed error is the lowest you can get with the selected parameters.
I'm a math person, and I see what you're doing. It's different enough though, that I think it needs explaining.
It is straightforward. All that is happening is that the C constant is being multiplied. If the C constant is 10 and 1/10, multiplying by 10 changes it to 101. Now a whole number. Because the newly resized C constant is used in the numerator and the denominator, any change to the feed rate is cancelled. That is, if you multiply the 1 constant by 10 also. Let me give you a visual example. The multiplier of 19 was determined through trial and error. 9 times 1 times 12 times 19 is equal to 2052. With a factor pair of 36 and 57. On the denominator side of the equation, 9 times 33 minus 1 times 19 is equal to 5624. With a factor pair of 76 and 74. Now I will set up the same problem with the C constant and the 1 constant, pre-multiplied by the multiplier, 19.
I can see the results are identical, but this sample doesn't offer a compelling reason for the change in method. Let me offer an example where the new method is compelling. The number of teeth is 48. The 1 constant is 1. The C constant is 11 and 1/4. The multiplier is 8. 90 times 1 times 12 equals 1080. With a factor pair of 30 and 36. And 90 times 48 minus 8 is equal to 4402. With a factor pair of 71 and 62. Compared to the old method, I can see where you'll get thousands of new possible index gear sets to choose from. That, in turn, will allow for much greater accuracy, or it will allow you to work with smaller numbers of change gears, if you are forced to.
The program is multi-threaded. The workload is divided equally between the threads for maximum speed. It selects all C constants that can produce the user's desired feed rate, then finds the lowest error feed gear sets. They are then sorted, with the best move to the top. No other software that I am aware of can match the accuracy of this program.